Hi Chem Peeps, here's another video on colligative properties using the application of some formulas that we saw in previous videos. In this problem, we're going to determine the molecular weight of a compound from its depression point for freezing. So let's look at the problem here. It says we have 1.07 milligrams of an unknown organic substance. So that is why we cannot just look up the molar weight on the periodic table, is because this is unknown. So let's continue seeing what else they give us. It was dissolved in 78.1 milligrams of liquid camphor. The resulting mixture had a melting point of 176 degrees Celsius. That's the mixture. That's the depression new freezing point. What is the molar mass of the solute? So in other words, we need to find the molecular weight of this substance, which means that we need to know the grams of it over the moles of it to calculate this. Okay? So what do they tell us? Well, they tell us that the camphor, the substance that's the liquid, has a melting point of 179.8, and it has a free K of F of 40 degrees Celsius per mol. Okay, so let's look here. We need to first look at the formula for the depression of freezing point. So we have change in freezing point is going to be the Van Hoff factor times the K of F factor times the mol. Okay, so what do we know already? Well, we know to find molality, I'm going to need the moles of solute, which we don't know it in particular, solute, all over the kilograms of solvent. So the first thing that I'm going to do is I'm going to take that 78.1 milligrams of solute, and I'm going to put it into grams. Okay, and so the first thing I'm going to do, or I'm going to put it in kilograms. Sorry, this is 78.1 is the actual solvent. So I need to have it right here. If we look, I need to have it in kilograms. So 1 kilogram is equal to 1 times 10 to the 6th milligrams. All right. So if I calculate that, I am going to get 7.82 times 10 to the negative 5th kilograms. So I now have the denominator for molality. The next thing that I'm going to do is I'm going to go ahead and I'm going to find that molality. So I know that the original freezing point is 179.8 degrees for the camphor. I know the new freezing point is 176 degrees Celsius. So the difference in these two is going to be the depression of it. Okay? The Van Hoff, because this is organic, covalent, it is not going to dissociate, so the Van Hoff factor is 1. We know the K of F is 40 degrees Celsius per mol, and we don't know the molality. We're going to solve for that. So if I solve for M, if I simplify this problem, I'm going to get 0.095, and that's going to be mol, which is going to be moles per kilogram. Okay, that's what the units are going to be. I need to know the numerator here for the solute. So if I take 0.095 moles per kilogram, and I multiply it by the kilograms that we calculated over here. Oops. So 7.82 times 10 to the negative 5th kilograms. That's over 1. See, the kilograms fall out, and we're left with the moles of solute. So it's 7.42 times 10 to the negative 8 moles. So if I want to find the molar weight, okay, right here, I need to take the grams that I'm given, and I actually have 1.07 milligrams of the solute. If I quickly make that into grams, I have, for every 1 gram, there's 1 times 10 to the negative 3 milligrams. Actually, it'll be a positive 3. Takes 1 times 10 to the positive 3, little milligrams equal 1 gram. So my answer is going to come out to be 0.00107 grams. So the molecular weight is going to be those grams, 0.00107 grams, all over the moles, which is 7.42 times 10 to the negative 8 moles. And my answer is going to come out to be 144.2 grams per mole. And that's the molecular weight of the unknown solute that we added to the camphor using depression or freezing point. I hope this helps. You can find more videos on colligative properties and other chemistry on TikTok and YouTube at Cam's Chem Chats. Leave a like or comment, and I'll see you in the next video.